All right, good morning. My name is Greg Wadley with CTC and Associates, and I'm the Clear Roads Administrator. We're here for the project final webinar for the project entitled "Update to," best management practices for liquid chloride storage and pumping systems. This research effort was led by Karen Klauser at Western Transportation Institute at Montana State University. Before I turn it over to Carolyn, I want to let everybody know that this webinar is being recorded and will be posted on the Clear Roads website later this week for viewing by you and your colleagues at your convenience. And we also ask that unless you're speaking, to please remain off camera and keep your microphone on mute. However, if you have any questions or comments, please enter them into the chat box and we'll address them at the end of the presentation. Right, I think that's everything that I have to say, so I'm going to turn it over to you, Carolyn.
Perfect. Thank you, Greg. Thank you, everyone, for joining us. This is the final webinar for best management practices for liquid de-icer storage and pumping systems. So today we're going to go over the content of the final report for this project. And just as a reminder, the goal of this project was to synthesize available information on liquid de-icing storage and pump systems currently being used across the U.S., and then the best practices for managing and maintaining these systems. So the two major outcomes of this project were a standalone best practices manual and then the final report, which we're going to go over today. Before I get started, I would like to take a minute and thank everyone who was involved in this project, my two co-authors, Mark Valenti and Laura Fay, the WTI communication staff, Neil Hetherington, Dana May, and Anna Price, who helped create some of the graphics for the manual and did all of the technical editing for this project, Greg, the Clear Roads Technical Advisory Panel members, and then everyone who participated in the surveys and interviews. Without your input and resources that were shared, this project would not have been as successful. All right, so this project involved 4 major tasks. We kicked it off with a survey of state and local transportation agencies, and then followed up with several of the survey participants and then vendors doing some more in-depth interviews to learn more. And then information from the surveys and the interviews were used to develop the best practices manual. And then there was a final report which covered all of the tasks associated with this project. So jumping into the survey was used to collect information on liquid de-icer storage and pumping systems that were being used across the U.S., and then those best practices and those lessons learned from those that have been, operating and maintaining these systems. The survey received a total of 49 responses from 27 states, and 34 of the respondents provided information about their storage and pumping systems. And what we found was there was not a consistent system being used across the survey participants. Instead, they helped to identify 19 manufacturers and 5 equipment suppliers of storage tanks, pumps, motors, and those fittings and piping. Focusing in on the lessons learned from the survey respondents, respondents were asked to share what parts they saw commonly failing or those parts that they're keeping on the shelf in case emergencies happen. So pumps, fittings, and hoses were by far the most common responses. Several respondents had noted failures as a result of needing some sort of preventative maintenance plan, including the need to keep this system cleaned and circulated and making sure that pumps and fittings are checked regularly. Nebraska DOT shared the need for operator training in order to reduce errors, and another respondent had specifically assigned personnel to keep their systems regularly cleaned and maintained. Several respondents highlighted failures in their pump systems. This included Caltrans, who mentioned that they had needed to switch from those plastic pumps to stainless steel pumps, noting that the plastic pumps were failing after just a single season of use. Maryland DOT mentioned that having issues with their system auger jamming during cleanout due to using dirty salt, and that because of this, they were now requiring salt vendors to provide solar salt. Respondents were also asked to share details on the best modification that they had made to their system. So several had modified their pump as a result of failures. And this included either upgrading to a larger pump or going from those plastic pumps to stainless steel ones. System coverings were also a common modification to help protect the system from weather and snow damage. Several lessons learned were shared by the survey participants. Number one was keeping the system clean and making sure that it's regularly the material that's stored in the tanks is being regularly recirculated. This would, keeping things clean included cleaning and lubricating pumps, flushing out pumps at the end of the season, using fresh water, and using clean salt if possible to avoid buildup in the tanks. Again, preventative maintenance was key. Massachusetts DOT noted that a lack of preventative maintenance was their biggest failure, and that since implementing a preventative maintenance program, that they had been able to increase their operations while reducing failure. Both the city of Columbus, Ohio, and South Dakota DOT noted that limiting the number of staff who operated their brine system had helped to reduce issues and ensure that the system was being operated and maintained in a consistent manner. Oregon DOT shared that they label all of the lines in their systems with the correct flow pattern to quickly isolate any system failures. And then finally, Idaho Transportation Department shared that they were protecting their system from snow sliding off of the tanks and hitting system plumbing by repurposing old traffic signs and creating little A-frame coverings. So after the survey, we followed up with several of the participants to learn more about their system and then some of the best practices that they had shared in the survey responses. So through this task, we were able to follow up with Alaska, Farmington Hills, Michigan, Iowa, Idaho, Kansas, Maine, Massachusetts, Nebraska, Oregon, and South Dakota. And I'm just going to run through the key takeaways and common findings from these interviews, but I do want to highlight that several of the best practices that were found in this task are in the best practices manual, which I'm going to talk about in a little bit. So for the liquid de-icer storage and pumping system facilities, several agencies mentioned to be prepared for your system to evolve over time and to not be afraid to get started and to start simple. This came up with both the Iowa DOT interview, where they talked about starting with this really grassroots approach and then building up their storage system over time as they had funding. And with the city of Farmington Hills, where they started out pre-wetting their salt using an overhead shower bar and have since built a state-of-the-art indoor liquids facility back in 2015. The folks from Fairbanks shared a really unique facility. So their system needed to be able to handle the extreme cold temperatures that they have in Alaska. So they cover their storage tanks with foam insulation and a weatherproof coating, which you can see in this top photo right here. I hope you guys can see my cursor. And then they have their tanks located next to their brine building. So all of the plumbing is insulated and then plumbed into that brine building to keep everything warm so things don't freeze anywhere in the system. City of Farmington Hills talked about their indoor liquids building, which is, there's one picture of it here at the bottom, where they had designed this indoor liquids facility to have a sloped floor. So any liquid or debris that gets spilled moves down the slope into a pit area that they can then clean with a Vector truck. Finally, several of the interviewees noted that ideally storage tanks would be located indoors in order to reduce UV damage and increase the lifespan of their tanks. Key takeaways for the storage tanks themselves. So having tanks on a regular replacement schedule can reduce those catastrophic failures. Idaho Transportation Department specifically noted that they replaced tanks on a 10 to 12 year cycle after they had 4 tanks rupture at 2 separate sites. Kansas, Nebraska, and South Dakota DOTs were utilizing fiberglass tanks, so they were kind of unique from the other interviewees. So they chose fiberglass because they found that it didn't fail catastrophically and instead tended to leak or seep. And another benefit of these tanks was they found they had more precise fittings. So they found that fiberglass tanks were cost competitive to poly tanks, particularly with those larger capacity tanks. Several tank condition testing methods were identified in the interviews. I'm going to highlight these later in the best practices manual section. And then most of the interviewees that we talked to did not have or need any form of secondary containment for their storage tanks. However, for those that did, concrete barriers were by far the most common, as you can see here on this picture from Oregon. For the pumps and motors, all interviewees were completing some form of end-of-season maintenance for their pumps. At minimum, this was flushing that pump out with water. However, several were also applying a corrosion preventative, and this was typically RV antifreeze or windshield washer fluid. Maine DOT shared a best practice where they mount their pumps and motors onto metal plates. And this allows their snow and ice supervisor to really quickly and efficiently swap out pumps and motors as needed for repairs. There's a picture of one right here at the top. Nebraska DOT shared that they had repurposed train sheds to use as pump houses, and this was helping to protect their pumps and motors from the elements. And then the last takeaway here was from Idaho Transportation Department. Again, this is where they were using the traffic signs to cover up their system plumbing. And this had been implemented because they had issues with snow sliding off of their tanks and damaging some of the plumbing to the tanks. Key takeaways for maintenance and cleaning. Several noted keeping things clean is key. Several also noted that they were using mined salt, which was causing issues with insolubles falling out of suspension. And this was resulting in like debris building up in the bottom of the tank and creating like a sludge at the bottom of the tank. City of Farmington Hills shared that they use an air purge system to clean liquid out of their fill point hoses. So this not only keeps the hoses clean and prevented contamination between liquids, but it also had a benefit of reducing the weight of the hoses for their operators. Several interviewees noted that they have a typical schedule for system inspections. So Iowa DOT was completing an inspection every spring and fall. Maine DOT has each site complete an in-depth inspection in the spring, and then every month they do a general building inspection, which includes things like putting eyes on the system and then recirculating any material that's left in the storage tanks. Some did share a formal checklist or guidebook, and these are shared in the report. And I'll talk a little bit about those later in the best practices manual. And then Maine DOT shared that they have a single person who travels statewide to help repair and maintain their liquid de-icer storage and pumping system. So this helped to ensure that repairs and maintenance were done in a consistent manner. And it also reduced challenges with locating necessary tools and parts in order to do any sort of repairs that were needed. And they found this position to be a really good use of time and resources. All interviewees mentioned that they were keeping some level of parts on hand for emergencies. The most common parts included spare pumps, fittings, clamps, seals, valves, and hoses. So in addition to the interviews with the transportation agencies, we reached out individually to all of the vendors that were identified by survey participants. And then additionally through the AASHTO Snow and Ice listserv to ask vendors to share their recommendations and their best practices for operating these systems. Through this outreach, we were able to touch base with 6 vendors. So Assman and Poly Processing, Daltmeyer, GVM, K-Tech Specialty Coatings, Snowbiz, and Veritech. So key takeaways from the vendors, they mentioned that both fiberglass and poly storage tanks have an expected lifespan around 15 to 20 years, and that locating those tanks indoors can reduce UV damage and increase the lifespan of that tank. Many of them noted that recirculation of the material in the tanks is key to keeping that tank in the long run. For this, K-Tech Specialty Coatings shared that recirculation is needed from the bottom of the tank to the top, but that this can cause foaming issues. So they shared what they called the cascading vortex design, which is over here on the right. This is where a 3 to 4 foot downspout with a 45-degree angled elbow is installed inside the tank to help with that recirculation of material without the foaming. The vendors suggested a couple methods for testing tank condition. This included, checking that tank periodically for cracks and crazing, so those hairline cracks. And then the baseball bat method, which is where you remove all the liquid from the tank and then you hit it with a bat and see how it reacts. For pumps and motors, vendors stated that pumps can be expected to have about a 2-year lifespan with proper maintenance, and this should include things like periodically flushing the pump with water and inspecting the seals and bearings. One vendor did recommend that locating pumps and motors indoors or utilizing some form of covering can help increase the lifespan of your pumps and motors. So now I'm really going to get into the major deliverable for this project, which was the best practices manual. So information that was collected from the agency and vendor interviews and surveys was used to develop this manual. And it's organized under the following sections. So there's introduction, there's system considerations, the equipment replacement program section, there's a maintenance and inspection section, there's case studies ranging with systems from those that are maybe starting out to in between to more advanced. And then with the manual, there were a few standalone deliverables that were developed. This includes an inspection checklist, what we're calling the 911 box, which is a list of recommended parts to keep on hand for emergencies, and then a safety considerations poster or flyer that could be hung up in a shop. So the manual starts out highlighting the steps for implementing new technology or equipment. This includes considering your goals, so thinking about what you need versus what you want, researching your options, so taking the time to learn about what's out there from vendors and suppliers, and then learning from your peers. So consider things like site visits or talking with your peers, maybe looking at some of the interview findings from this project, just reaching out and learning from others that have used these systems. Next, think about your unique situation. So what are your storage needs? Do you have electricity on site? Are you going to purchase brine or manufacture brine? All of these things will come into play. Then think about your future operations. So this is really where you're setting yourself up for success by planning for your future growth and then planning for equipment replacement so you can be proactive rather than reactive. And then finding your happy medium. Next, the manual walks through considerations for the various system components. So starting with storage tanks, it walks through the pros and cons of poly versus fiberglass tanks. So for poly tanks, they're available in a variety of sizes, including smaller sizes. They tend to have a lifespan of around 15 to 20 years, and they may be cheaper than fiberglass. However, they are prone to UV damage and they can catastrophically fail, resulting in loss of product. For fiberglass tanks, they tend to be available at those larger capacities. They have a lifespan of around 20 years. They do tend to have more precise fittings and will not fail catastrophically, but instead will tend to seep or leak. However, they tend to be more expensive and they are also prone to UV damage. So beyond the tank material itself, there are several considerations. As I mentioned, both poly and fiberglass tanks are prone to UV damage, which can cause that tank to become brittle over time. So an agency may want to consider locating tanks indoors or under a covering to prevent this damage. However, this is not always an option due to site characteristics or cost. The end location of tanks can significantly affect transportation fees when purchasing a tank. So purchasing tanks through nearby vendors may be most cost effective for an agency. And then once that tank is on site, some things to consider include whether your agency has the appropriate equipment and staff training to lift these oversized and awkward objects, or whether you should bring in someone that can safely set that tank in place. Next consideration is for the specific gravity rating of the tank or its ability to hold materials. So the storage tank should have a specific gravity rating higher than the specific gravity of the heaviest liquid, which will be stored within the tank. Next, system plumbing is discussed. So that plumbing should include multiple shutoff valves between tanks to allow for isolation and redundancy. This helps to isolate any problems, prevent contamination between tanks, and prevent any loss of product should there be a failure. Finally, the manual discusses the material for the storage tank foundation itself. So concrete, sand, and Portland cement are recommended materials as they will allow the tank to safely expand and contract with varying temperatures without causing any damage to the tank. Next, the manual discusses secondary containment, so preventing those spills or the release of substances into the environment should a tank fail. So every state and organization has different requirements for secondary containment of de-icers. And most of those that we spoke with in the interviews task and through the surveys were not utilizing any form of secondary containment. For those that did require secondary containment, generally this should accommodate 110% of the capacity of the single largest storage tank in your tank farm. And containment options included things like containment basins, double-walled tanks, concrete walls and curbing, depressed flooring, building drainage, and retention basins or ponds. In this section, we highlighted the Oregon Secondary Containment Risk Assessment form because it provides a really great guide to help your agency determine if they should think about secondary containment. So this form walks through several factors, including drainage around the tank, the presence of nearby surface water or other sensitive water sources, the presence of nearby agricultural or residential areas, and you will total up and it'll kind of put you at a low to high risk for secondary containment. So this provides a nice guide for those that may be thinking about something like this. Next, the manual discusses truck fills. So in determining the appropriate pumps, motors, and pipings for truck fills, there are several questions to consider. So first, what are you filling? Are you looking at a lot of things like saddle tanks, which are upwards of 500 gallons, to those larger direct liquid application units, which are upwards of 5,000 gallons? So then think about whether you need variable flow pumps. So if your agency is filling multiple sizes of truck tanks, then a variable flow pump might be the most effective, as you can adjust that flow rate depending on the size of the unit that's being filled. One note here, and I'll talk about this again in the safety considerations section, is pump capacity can range depending on the hose diameter, but when determining hose diameter, remember that the weight of that hose with liquid moving through it can get heavy really quick. Just thinking of safety of your employees. Next, the pump and motor material is discussed. So this is generally selected on overall budget and whether that pump's for the short or long-term use and whether you have the ability to rebuild pump components in-house. So plastic pumps are cheaper, however, they're not as effective if the liquid moving through it has too much solid or grit. Stainless steel pumps can be more expensive, however, they do tend to have a little bit of a longer lifespan and they have that corrosion resistance. Some truck fills have the ability to track data on material use. So the manual does walk through some things to consider when determining whether you need this data recording capability. This includes thinking about what data is already being collected within your agency. So maybe through things like spreader controller data, whether you have multiple agencies using a single truck fill where that data recording can help with invoicing or auditing. And then whether your agency is trying to reduce chloride use or chloride use is a concern, so where you can kind of track the use of chloride over time. So for truck fills, there really is no one-size-fits-all solution for determining how many truck fills your agency should have. Instead, we recommend considering the number of units filling at the location, how large the tanks are, what the cycle time is per truck, and then what is an acceptable wait time. And then to keep in mind that your truck fill can be built out over multiple seasons in a modular format as needed. The equipment replacement program section highlights all of the factors which are going to impact the life cycle of your equipment to help prepare an agency to keep these things on a consistent maintenance and replacement cycle. So for storage tanks, the expected lifespan is upwards of 20 years with proper care and placement. Things to consider include the tank materials, so poly versus fiberglass, the tank location, whether it's indoors and covered, protected from that UV damage, which can increase the lifespan. Making sure that the tank is properly ventilated during the warmer months, and then making sure that the tank is the appropriate specific gravity rating for the material that's being stored within it. For truck fills, an expected lifespan is 10 to 15 years before full replacement. Again, things will last longer with proper care and maintenance. Hoses will last about 10 to 15 years on average, as long as they're not being left outdoors, exposed to the elements, dropped, and driven over. To properly maintain equipment, routine inspections should be utilized. So a preventative maintenance plan that has several sets of eyes on the system looking for issues can ensure that things continue to run smoothly. So most agencies are completing an inspection before the winter season and then again in the spring. However, additional periodic checks of the system can help the agency proactively catch issues as they arise instead of reacting to major issues. So for this, we used some of the inspection checklists that were shared with us from the interviews task, and then Mark's expertise to develop an example inspection checklist. So the manual includes two versions of the checklist, one for systems that do have a brine making unit, and then for those without. The checklist walks through each piece of the system in a follow the liquid format. So for the version on the slide here, that does include the brine unit. It goes from the feed line to the brine unit, to the brine tank, to the truck fill. So each row in the checklist includes things to look for in italics, and then whoever's using it can check the condition. So is it okay? Does it have minor issues, major issues, or is it not applicable for your system? And then comments can be added here on the right. So for the feed line from the brine unit, the checklist includes looking for leaks, checking and lubricating fittings and valves, checking the piping, and then ensuring that if there is an air purge, that it is operational. For the brine tank section, users will check intake fittings, valves, the access port, whether the tank is breathable, whether it needs to be cleaned. They'll check the tank for visible cracking, stress, or deformations. Then check any lighting, the outlet piping, and whether the material in the tank has been recirculated. And then the last section of the checklist covers the truck fill. So this again has, you look for leaks, check and lubricate fittings and valves, examine that piping, including whether it's safely manageable by staff. And then if there is an air purge, making sure that it's operational. Last, the checklist has users make sure the pump has been properly maintained for post-season. We also provide several methods to test the condition of poly tanks. So these include the water test. So when you purchase a tank, filling it with water first and checking for leaks before putting in expensive de-icing chemicals. Reading the cracks, so examining the tanks for any cracks or crazing, so those hairline cracks. The tank scrape test, so this was shared by Maine DOT, where they will scrape the tank in areas where they have concern with a screwdriver, and if the material comes back powdery, then that indicates to them that there's some deterioration going on. The marker test, this one was shared by Oregon DOT. This is where you take a water-soluble marker and you fill in areas of concern, and then you wipe off the excess ink from the marker, and this the cracks will remain filled with ink. So it's just a way to help kind of visualize cracking that's going on. There's the light test. So this is where you remove product from the tank and then lower a light into it. And then stress points will show up as areas of different light intensity. And then last is that baseball bat test. So you remove all the product from the tank and then you hit it with a bat to see how it reacts. We then highlight some of the maintenance best practices that were shared in the agency interview. So first is recirculating the material in the tank. This is particularly important for de-icer products that contain fines or insolubles or contain blended chlorides and organic components where you have things falling out of suspension and potentially building up in the bottom of your tank. So for this, we shared Maine DOT's calculation to determine how long to recirculate the material in the tank, which is based on the number of gallons stored in the tank and then the size of the pump that's being used to recirculate the material. We discussed some storage tank cleaning options. So most agencies are using a Vactor truck and pressure washer, but it does discuss how some are contracting out this cleaning in order to avoid having to maintain additional equipment. We shared the City of Farmington Hills air purge system for their fill point hoses. And then last, it discusses end of season maintenance for pumps and motors. So this includes flushing that pump with water, using a salt neutralizer, and then potentially using a corrosion preventative like RV antifreeze or windshield washer fluid. The manual then shares some best practices for repairs. So this includes the consideration of having a more statewide or regional maintenance supervisor to ensure that regular maintenance and repairs are being done in a consistent manner. We shared the best practice from Maine, where they have their spare pump and motor setups mounted to plates, which can be easily swapped out for repairs. And And then last, this section talks about keeping parts on hand to be able to quickly handle repairs as they arise. So most local depots are keeping a smaller stock of parts on hand, like hoses, clamps, and fittings. And then some will have a central storage of parts, which will include larger items like pumps and motors. So for this, we did create what we're calling the 911 box. So this is the recommended parts and supplies list to keep on hand. So for that local depot, assuming 2 tanks and 2 truck fills, it has those local depots keeping things like hoses and then fittings, pressure clamps, gaskets, and valves for each hose diameter. And then at that central facility, which is serving potentially 4 to 6 local depots, you're looking at larger amounts of hoses, fittings, pressure clamps, gaskets, valves for each hose diameter, and then truck fills and truck fill pumps and motors, and then 1 truck fill station that's ready to go. And then each agency should consider things like whether they can easily obtain replacement parts, maybe from a nearby vendor, and then what level of downtime is acceptable, as this will really help you to determine what level of parts to keep on hand. Next, since working with these systems can be dangerous, we also developed the safety considerations poster or flyer. So this includes things like personal protective equipment to keep on hand, like safety glasses, gloves, long sleeve shirts and pants to protect you as you're working with these systems, lockout, tag out when working with electrical equipment, a reminder that the storage tanks are a confined space and that OSHA regulations should be followed regarding confined spaces, pinch points when working with pump impellers, lifting and handling equipment, including a reminder on how much that fill point hose can weigh when it contains liquid, systems under pressure, including reminders to check for secure fittings, sharp edges, and then slippery conditions. And we developed this thinking it could be something that could potentially be hung up in a maintenance shop. This is a gentle reminder. So the last section of the best practices manual walks through some case studies which describe liquid de-icing storage and pumping systems ranging from starting out to in between to more advanced. So each case study provides examples of typical equipment you could expect to see, a description of what you can expect out of that system, the potential costs, personnel requirements and trainings, and then next steps. So if you were going to build upon that system, what would the next step look like? So for a beginning or starting out system, you're looking at a cost of upwards of $5,000. These systems are very simple. So you're looking at a single liquid system with no blending capabilities. Those truck fill pumps would be off the shelf with a single flow rate. And the valve systems are simplistic, allowing for isolation from the tank and the pump. So because these systems are pretty simple, you can expect the bare essentials of salt brine application. So you'd have the ability to manufacture salt brine and fill salt brine application units. Personnel and training requirements are pretty minimal. However, extra attention is needed when filling trucks because there's no shutoff or overflow alarms. So turning that pump off is based on visual inspection only. And then when you're looking to build upon this basic system, you're referring to your wants list. And then we recommend planning deliberately to try to build out your system in a modular format so you can improve upon things as funding allows. For an in-between system, you're looking at a cost of upwards of $20,000. So for these systems, you're looking at things like manual blending capabilities. The system valves are becoming more complex, allowing for each tank to be isolated from one another and the truck fill, and things like stainless steel pumps, which can be rebuilt or repaired. For the in-between system, you can expect stack blending. So as liquids are loading into the truck, they blend themselves as it moves around in the tank. Blending is done by visual means or timing the flow of the liquid to determine the volume being dispensed. So these systems do require extra attention when blending and need trained staff because there's lots of moving parts and things that can go wrong when valves are open and closed during mixing and filling. So then when you're looking to build upon this in-between system, you're really looking at those more advanced systems with features that would help automate operations. So for the more advanced system, you're looking at costs upwards of $40,000 and above. The more advanced systems have features like automated blending, These systems allow you to create some pre-programmed blends in the form of percentages of each product. These systems tend to have data logging capabilities and can allow for remote access into these systems. And then another perk of the advanced system is that variable truck fill rate, which is extremely beneficial for agencies that are filling up a variety of truck units. So those automated systems really create an easier environment for operations staff, and they may reduce the oversight and supervision required to ensure that the operations staff are using the correct products, especially when you're using blends. However, these systems do have advanced training requirements. OEMs that create these advanced systems do tend to offer training, and they do also have the benefit of generally being able to remote access in to troubleshoot issues that should arise. So advanced systems are often built with a modular construction in mind. So when you're looking to build upon these systems, you're looking at replacing and enhancing what you need instead of needing to invest upon a whole new system. So wrapping up this project, in summary, we did not find a single one-size-fits-all de-icer storage and pumping system amongst the survey and interview participants. Instead, these systems were all built to fit each agency's needs and funding. However, some of the best practices and lessons learned from those operating, maintaining these systems can help support other agencies as they look to maintain their existing equipment or look to implement new technology. First is to not be afraid to start simply and build your system out over time. And then make sure that you're setting yourself up for success by planning for your future operational needs. Some additional best practices include that keeping in mind that your system lifecycle planning is going to evolve and you need to be flexible. Make sure that you're being proactive rather than reactive to system maintenance by regularly inspecting and maintaining your system components. Thinking about developing an inspection checklist or using the one that was developed as a part of this project to ensure that your employees are keeping an eye on the system in a regular and consistent manner. Keeping a stock of supplies on hand for emergencies to help avoid potential downtime. And then last, to not forget about the safety of your employees who are operating these systems. So throughout the project, there were some future research needs identified. The first was the need for technology transfer. So throughout the survey and interviews, we heard from several folks a desire to learn how others are operating and maintaining these systems, and particularly how they're solving problems that arise. So this really highlighted a potential need to either create training materials related to the findings of this effort or present them at conferences, but it also highlighted a need for ongoing tech transfer through things like a working group or roundtable that meets periodically to share experiences and allow others to learn from their peers. Next, research need included an examination of what we're calling the no tank option. So some agencies could skip storage tanks altogether and have a direct truck fill from their brine system to help eliminate some of the challenges of maintaining this equipment. However, the truck fill option is only possible in certain conditions, and that brine system needs to be able to manufacture brine at a rate within a standard truck fill rate. So this research effort could examine that no tank option further and make recommendations. The last is an examination similar to this effort, but focused on the brine making units themselves to learn about the best practices and lessons learned from those that are operating those systems as they were outside of the scope of this project. So with that, I am going to stop for any questions. I just threw a lot of information at everyone.
All right, thank you, Carolyn. I appreciate it. Just one comment on your previous slide, and that is that Claire Rhodes actually is conducting a synthesis on brine making practices.
Okay, perfect.
It should be wrapping up, well, this month actually. So
cool. Oh, we'll have to watch for that.
Yeah. All right. So I don't have any questions or comments in the chat box. I did ask you to keep your microphones on mute during this process and to put anything in the chat box. But since she's now done with her presentation, if you do have any questions, I say just go ahead and raise your hand or take yourself off mute and speak up.
I just wanted to say what a great job Carolyn and Mark you guys did in assembling a bunch of great guidance from different states that have met different challenges for their environments. Thank you very much.
Thanks, Mark.
Thanks, Mark.
Yeah, this is Chris. I was a little bit late, but just to echo what Mark said, again, thanks for everything. I thought it come out great. I passed some of it on to my snow and ice technician up here, and he's putting some of the things into use. So
Oh, cool.
Nicely
That's great
done.
to hear.
it's awesome. Thank you.
Thanks, Chris.
Thank you, Chris.